Dear students, welcome back to my YouTube channel, and you get my previous videos from my personal homepage or from my channel. And we are going to discuss the new topic which comes into advanced topics and applied chemistry, and module 6 applied organic chemistry, the first one. And here we are going to discuss the petroleum products and carbon range and uses of various fractions of petroleum distillation, and what is petrol and what is knocking, octane number, anti-knocking compounds, and diesel oil, cetane number, flash point, and the composition and uses of LPG and CNG gases. And the origin of petroleum is a small marine organism including microscopic small sea animals and plants which buried with sand and mud over 3,000 million of years under high pressure and temperature with bacterial action. Petroleum is trapped in porous rock by layers of non-porous rock. So what is actually petroleum? It is also known as crude oil, and its appearance is thick and smelly oily liquid, and color ranges from greenish brown to black depending on where it is obtained. And it is a complex mixture, mainly consists of hydrocarbons, that is compound made of hydrogen and carbon only. Other compounds such as sulfur, nitrogen and oxygen combined with carbon and hydrogen are also found. The major constituents of petroleum is alkane, which is a homologous series of hydrocarbon. And in this slide, I'm going to take you different carbon range and what is meant by fractional distillation. Since petroleum product is a complex mixture of hydrocarbons, you have to get separated. So this is a diagram of distillation column used for separating petroleum fraction. Petroleum fractions condense at a different temperature depending on the number of carbon atom in the molecule, and after that it is drawn off from the column. And you can see that crude oil consists of different fraction having the number of carbon in different range. And for example, gases having the carbon range 1 to 4 and having lower boiling point 30 degree, and which is used in bottled and natural gas. Whereas naphthas having carbon range 5 to 10 and having boiling point 30 to 180, it is used as a gasoline. And kerosene with range 10 to 16 having boiling point, a very high boiling point when compared to this, and you can it is used as for home heater and jet fuel. And similarly you can see the different fractions, gas oil, lubricant, fuel oil and asphalt, and having different carbon range. And when you go the higher number of carbon range, the boiling point of the fractions or boiling point of the product get increased. And these are the uses of different fractions of crude oil. So this is the enhanced image of this distillation column. And what is the refining work of petroleum? That is, the petroleum gets separated in this refining process, fractional distillation. And as I said, the substances in crude oil are miscible, therefore they do not separate into layers. Therefore, fractional distillation, which is carried out in the fractionating towers, is used in refining petroleum. Fractional distillation is the process of heating up a mixture containing different substances with the different boiling points and drawing the different fraction off. Each fraction is not a pure compound but is a mixture of different alkane with a similar boiling point. And most of the substance in the crude oil evaporate. The mixture of vapors then passes out the tower. The tower is steadily cooler towards the top because the different hydrocarbons have different boiling point. They condense at different levels up the tower. And special trays collect the condensed liquid and it runs off in pipes. As you know, the higher the number of carbon molecule, the higher is the boiling point. Hydrocarbons with a high boiling point condense first with the low down the tower. The lower the boiling point fraction, the higher the level of fractionating tower it can reach. So it reach the lower the boiling point fraction will reach the tower very easily, the top of the tower, and cooled off from that fractionating column, and it goes to the pipe. So it gets separated. And this is the method that is used to separate different products of crude oil. So next one is octane number. What is meant by octane number? It is related to knocking in internal combustion of engine. Knocking means in internal combustion engine, and that's petroleum engine, the fuels are gasoline and gasoline vapors plus air. So burning of fuel is initiated by a spark in the cylinder. It creates a spark, burning of fuel, and due to combustion, the gases are formed which moves piston down the cylinder. So the movement of piston is uniform without any vibration. So knocking means the process that happens within combustion chamber. It sounds like a small tickling or rattling noise in petroleum engine. Uh, okay, so that knocking may be due to the factors that contribute to the knocking, that sound when you start the engine, maybe due to increased compression or advanced ignition timing or lean in fuel air mixture, or this is the important point that I want to highlight, the lower octane of fuel, octane number of fuel. So that is we want to learn. What is mean by, if you have a lower octane number, it will not create knock. So octane number, it reflects the fuel's resistant to knocking. It's a standard measure of performance of an engine or aviation fuel, and it is defined by comparing with 2,2,4 trimethylpentane. This is 1, 2 and 2, 2, 4 trimethylpentane, that is called isooctane, and heptane. So fuel containing large number of straight chain hydrocarbons, that is this one, heptane, possess more knocking tendency. Now normal heptane knocks very badly and its anti-knock value is 0. Whereas a petroleum contains isooctane, it gives only very little knocking and its anti-knocking value is 100. So a petrol contain more isooctanes, it will be having less knocking and its anti-knocking value is 100. So it is a measure of auto ignition resistance of gasoline, and you can say higher the octane number, the better is the resistance of gasoline to combustion prematurely. But if combustion occurs prematurely, knocking occurs. So isooctane is a given maximum octane number 100 and normal octane is minimum octane number 0. And octane number is actually a measure of fuel's auto ignition or premature delay. So auto ignition should take place in uniform and correct time. If there is a delay, so it produces knocking. So a petrol having very good octane number, that is a 100 octane number, will give very good auto ignition. There is no auto ignition. There will not be auto ignition delay. So knocking can be prevented by using good quality of fuel with a higher octane number, and also is possible by adding anti-knocking agent, and which can correct ignition timing. Anti-knocking agents are tetraethyl lead, still used as a high octane additive, and alcohol can be used, and methyl cyclopentadienyl manganese tricarbonyl can be used, ferrocene and iode pentacarbonyl, and toluene and isooctane. And coming to diesel fuel, Liquid fuel used in diesel engineering, whose fuel ignition takes place without any spark. In previous case, it was due to spark, and in diesel fuel, as a result of compression of inlet air mixture and the injection of fuel, uh, there is no fuel ignition, auto ignition. But here there is a glow plex grid heaters and heater blocks. It helps to achieve high temperature for combustion during engine startup, even in cold weather. So, what is Cetane number? It is similar to octane in a petroleum engine, and it is a diesel engine. It is Cetane number. Cetane number of diesel fuel refers to the ease with which the fuel ignites. The best diesel fuel is that which ignites readily and burns rapidly. The Cetane number assigned to a diesel fuel, it is a measure of its ignition qualities compared to those of standard fuel normal cetane. And this is cetane. It is an hydrocarbon. Cetane means C16H34. That is a hexadecade. So Cetane number is a measure of combustion quality of diesel fuel under compression, and a higher Cetane number means the diesel fuel will ignite readily and perform better. And normal hexadecane is given a maximum Cetane number 100, and 1 methyl naphthalene is given minimum Cetane number 0. Cetane number is a measure of fuel's ignition delay, the time period between start of ignition and start of combustion of fuel. The higher octane fuel having shorter ignition delay than the lower cetane fuel. So next topic is what is mean by flash point. Flash point is the lowest temperature at which a liquid, usually a petroleum product, will form a vapor in the air near its surface that will flash or briefly ignite on exposure to an open flame. Flash point is a general indication of a flammability or combustibility of a liquid. Below flash point, insufficient vapors is available to support combustion. At some temperature above the flash point, the liquid will produce enough vapors to support combustion. This temperature is known as fire point. And a flash point is a descriptive characteristic that is used to distinguish between flammable liquids such as petrol and combustible liquids such as diesel. It is also used to characterize the fire hazards of liquids. Liquids which have flash point less than 37.8 degrees Celsius are called flammable, whereas the liquid having flash point above that temperatures are called combustible. And flash point is the lowest temperature at which a liquid can form an ignitable mixture in air near the surface of liquid. And the flash point is the lowest temperature at which vapors of volatile material will ignite when given an ignition source. The lower flash point, the easier it is to ignite the material. For example, gasoline has a flash point of minus 40 degree and more flammable than diesel, which has a flash point of 38 degrees. Next one is what is mean by LPG, liquefied petroleum gas, and CNG, compressed natural gas. It is methane gas is CNG gas. Methane stored at high pressure is shown here, and this is LPG is usually propane or butane gas. CNG, it is compressed natural gas. It is cheapest, cleanest, and least environmentally impacting alternative material. And vehicle powered by CNG produces less carbon monoxide and hydrocarbon emission, and it is less expensive than petroleum and diesel, and is safer than other fuel in the event of spill because natural gas is lighter than air and disperses quickly when released. And it is used in heating, cooking, electricity generation, and industry. And it is also used to production of synthetic materials such as paint, fertilizers, and plastic extra. And liquefied petroleum gas, it is a colorless, odorless gas, and is a flammable mixture of hydrocarbon gases used as a fuel in heating appliances, cooking equipment, and vehicles. Mostly consists of mixture of propane and butane, and a small amount of propylenes and butylenes are also present. As its boiling point is below room temperature, LPG will evaporate quickly at normal temperature and pressure, and is usually supplied in pressurized steel vessel. And burning LPG releases carbon dioxide and greenhouse gases. Thank you for watching.